Hi, everyone. My name is Milka Trajkova, and today Dr. Alhakamy and I will present her work with Professor Cafaro titled, Show Me How You Interact, I Will Tell You What You Think, exploring the effect of the interaction style on user sense-making about correlation and causation in data. The purpose of this study is to explore how users' interaction with the data visualization contributes to how people make sense of causation and correlation across data sets on display. Why is this important? In today's world, people produce 2.5 quintillion bytes of data per day while searching for information on the internet, using social media, reading, or listening to debates. In such a context, being able to make sense of data is a particularly crucial skill because more and more people have relied on their own data analyses to inform their personal and business decisions. As the data gathering and visualization of large data sets becomes central to people, museums have attended to ways of presenting data to visitors, including with large displays that people can control with gestures and body movements. Findings from embodied interaction and embodied learning indicate that our body, not just what we see with our eyes, plays a significant role in the way that we learn and understand abstract concepts. In particular, in cognitive linguistics, Lakoff's and Johnson's theory of conceptual metaphors posits that humans gain an understanding of the world using a small set of basic mental patterns, or embodied schemata. These schemata arise from our experiences using our bodies and are acquired at a very young age. They create networks of brain circuits that shape and constrain our thinking and sense-making. Designing installations that facilitate data exploration is, however, still a challenge for human data interaction. Specifically, we need to identify design strategies that quickly enable people to focus on the data on display and to discuss insights on the data. Within this scenario, this paper focuses on two specific concepts, correlation and causation. Correlation and causation can be difficult to interpret. On the one hand, confounding correlation with causation may lead people to assume causality when there is not. On the other hand, the mantra that correlation does not imply causation may conceal how correlation can be a precious hint to causation and lead people to question the validity of scientific findings. Specifically, we designed a study to answer the following research questions. The first is, how does the interaction style, full body versus gamepad, affect the user's agreement with statements that imply either correlation or causation across the data sets on display? And the second we were interested in asked if there were any categories of schemata used more or less frequently depending on the interaction style. My colleague will go on to explain the system implementation followed by the experiment design.
For our system design and implementation, we have four major components: sensor controller, gesture manager, and dataset designer, and the Gamepad manager. The sensor controller is connected with the gesture manager, and we have the dataset designer in the middle, which is connected to both type of interactions here. So either the person can control the system using the gesture or using the Gamepad manager. For the data sets, we present two data sets that have a relation or could have a relation between them on two separate globes. And then we have here several functionalities where the person can control these data set and how it's presented. For instance, the person can rotate the globe either using the wheel movement or they can use the joystick on the gamepad. For zoom in and zoom out, they can use the hand gesture for zoom in or zoom out, or they can use the buttons on the gamepad, A and B, we chose it here. For changing the data set, because we have several questions here, they can either jump or swipe to change the data set. For the gamepad, they can use the D-pad. Lastly, we have controlling the cursor. There's a cursor on the screen. The person can control that to fly to a certain continent using the grab movement and touch, which work as click and push. For the gamepad version, if they can use, after selecting this button for changing the continent, they can use the D-pad to go through which continent. Is it North America, South America, or any other continent? Then press X to select. We have two experimental conditions here. So we conduct a mixed method in a lab study with the 20 users in two experimental conditions. The full body is the first condition, where participants interacted with 65-inch display showing geo-referenced data using gestures and body movement. The second condition is the gamepad, where people use the joystick to control the system. And now with my friend Milka and colleague to discuss more.
The experiment sessions followed a testing protocol consisted of the following 3 steps: a pretest questionnaire, the interaction with the prototype, and a post-test questionnaire. The pre- and post-test survey, including matching Likert statements, related to correlation and causation using 4 datasets. The interaction consisted of either the full body or gamepad, where participants were asked the following 2 questions. We transcribed and analyzed the qualitative data in 3 rounds using discourse analysis based on the catalog of embodied schemata. The quantitative data was cleaned, and we computed the average agreement scores in each of the pre-post-test scores. For more information, please refer to our paper. Now for the results. For the first research question, we conducted a 3-way ANOVA, exploring the effect of test time, pre- and post-test, question type, correlation and causation, and interaction style, full body and gamepad, on the agreement score. We found a statistically significant simple main effect of test time in the gamepad interaction style. Specifically, the average score decreased from the pre-test to the post-test. Regarding the specific categories of schemata, we identified 144 idea units and conducted a log linear analysis that detected a statistically significant difference in the use of force schemata between the 2 interaction styles. Specifically, the odds ratio of participants reasoning using force schemata when they interacted with the gamepad was 20% of the odds of participants using force schemata when they interacted using their full body. In other words, participants were made remarks based on the force schemata 4 times more frequently while they interacted with gestures and body movements than when they used a gamepad. In summary, our results indicate that the interaction style, gamepad versus full body, influences how users make sense of correlation and causation. The difference in people's agreement with statements that portray correlation or causation between pre- and post-tests depended on the interaction. There's an increasing body of research that demonstrates that hand gestures play an important role in scientific reasoning in classrooms. Thus, we believe that the specific gestures may play a particularly important role in building reasoning about data, even beyond formal learning settings. Our discourse analysis findings suggest that the sequence of causality intrinsic in force schemata may prime people towards seeing causality and correlation across the data set on display. Future work should further investigate this phenomenon by comparing additional interaction styles, data visualizations, display sizes, and data sets. Thank you for your interest.